What is this? Implicit differentiation. Well, if I'm given a function, let's say f of x equals e to 2x plus 5x cubed, there is no problem there. The function is given to us explicitly. And all we have to do is just find f prime of x, which is 2e to 2x plus 15x squared. So when the function is given to us in an equation, it's not spelled out. It's not given to us, but it's part of an equation. The function is not given to us, or if you want, it's given implicitly, then the equation may look like this. So let's say x squared plus y squared equals 25. So let's suppose, I selected a problem. I'm going to open the book in a minute. So I selected, what did I select? 4 on page 359. You're going to select the next. Now, yes, I can use the notation y prime. Yes, I can use the notation f prime or f prime of x. But if I'm given an equation and I am not given y equals or f of x equals, I should be using the notation dy over dx. And not, which is the same thing with y prime, is the same thing with f prime of x. But this is the preferred notation when I'm asked to find the derivative of y. So again, the equation that is given to us is this. I'm asked to find dy over dx. What does this mean, first of all? When I look at dy over dx, first of all, I understand that I'm asked to find f prime of x. And I'm also understanding here, very important, I also understand that y is a function of x. So this is just the independent variable, but this is basically a function of x. That's what this notation is telling me. Otherwise, they wouldn't ask me to find the derivative of y with respect to x if y wouldn't be a function of x. So here is how we find dy over dx by implicit differentiation. Here it is. Again, x squared plus y squared equals 25. I differentiate the left-hand side and I differentiate the right-hand side. It's the same as the process. Let's say I have x plus 1 squared equals 4. I apply the square root to both sides to get x plus 1 equals plus or minus 2 and x equals negative 1 plus or minus 2. And of course, I get positive 1 and negative 3. So what I did to the left-hand side, I did to the right-hand side. Same thing here. I differentiate the left and I differentiate the right. When I differentiate the left, here I get 2x. But here, it's a different story because it's a function of x to power 2. I bring down the power. I subtract 1 from the power times the inner function prime. And when I differentiate a number, I get 0. The next step, I have to solve for dy over dx. I will move 2x to the other side. I will divide both sides by 2y. And I get negative x over y. Now you can say you haven't accomplished much. You found an expression for the derivative, but it depends on y. And you don't have y. True. but I have an expression for the derivative, and that's all I was asked to do. So given this equation, because I was not given the function explicitly, I was only given an equation, that's all I could do. And I was asked, find an expression for dy over dx. And I did. So now I'm going to open the book so you can choose something else, anything you want. Clicking, clicking, clicking. Okay, vital source. Okay, almost there. And the page is 359. Okay, text chapter 3, open 359. Okay, 359. That's all there is to it, but of course we have to practice. Okay, differentiate implicitly to find dy over dx. Differentiate implicitly to find dy over dx, then find the slope of the curve at the given point. And then differentiate implicitly to find dp over dx. So let's choose. I started with number 4. So please choose the next problem so we can practice implicit differentiation.
15.
Very good. Let's take a look. 15, good. Good one. So 3x cubed minus y squared equals 8. And they want us to find the slope of the curve at the given point, which is 2, 4. Very good. So in order to find the slope will be dy over dx when x is 2 and when y is 4. That's the question. It says find the slope to the graph of this curve at this point. Now, I'd like to go back and check and see. So 3 times 4 is 12. So 4 times 3 is 12 minus, what are they doing? Did I copy something wrong? Oh, yes, I did copy something wrong. Okay, the point has to be on the equation. It has to verify the equation. So 24 minus 16, that's 8, correct. Good. So the question here is, find the slope, which is this, at this point. So determine an expression from the given equation, determine dy over dx like we did before. And then when you're done, replace x by 2 and y by 4 to see what is the slope of the tangent line to the graph of this curve at this point. So like before, we have to use implicit differentiation. What we do to the left, we have to do to the right. So here is 9x squared minus, careful, 2y dy over dx equals 0. Move 9x squared and divide by 2y. So dy over dx, this will be negative 9x squared over negative 2y will be 9x squared over 2y. So I have an expression for the slope of the tangent line to the graph of this at this point. But now all I have to do is We normally put that bar. So when x is 2 and y is 4, no problem. So 9 times 4 divided by 2 times 4. So the slope, sorry about that. So the slope of the tangent line to the graph of this at the point 2 comma 4 is 9/2. That's it. Any questions? Okay, let's practice some more. Is there anything else that you would like to choose from here? Anything?
19.
19, very good. Let's take a look at 19. Good. And that's my page 3. We are looking at 19. And in 19, we have x squared plus y squared equals 1. And the same thing at a different point, which is, so 1/4 plus 3/4 is 1. That's correct. This is the point on the given equation. Good. Same thing. I differentiate both sides. 2x, 2y, dy over dx equals 0. I have dy over dx. This is negative 2x over 2y will be negative x over y. All I need to do now is plug in x as 1/2 and y as the square root of 3 over 2, negative. The top is 1/2. The denominator is the square root of 3 over 2. When I flip, I get negative 1 over the square root of 3. I should rationalize and write negative the square root of 3 over 3. So this is the slope of the tangent line to the graph of this equation at this point. Any questions? Any questions?
Ms. Lead, I got lost on the previous example that we
Yes,
did
let's take a
with
look.
the end.
Please, let's take a look.
I'm
Yes.
sorry, I just got lost where we plugged in the numbers where it's dy over dx equals 9x squared over 2y.
This one here? From here, or
Yes.
from here, here?
No, the last part.
So 2 squared is 4. Y is 4. 4 with 4 went away. 9/2. Is that okay?
Yes, thank you.
My pleasure. Anything else? Other questions here? Okay, feel free to choose. If not, I will. I would like to work on at least one more.
We need 32.
32, very good. 32. And 32, we have x cubed p squared equals 108. Differentiate to find dp over dx. So dp over dx is the derivative of p, and also it tells us that p is a function of x. Good. Very good. So I differentiate the left, I differentiate the right. What formula or what differentiation rule I will have to use here at x cubed p squared?
Product rule.
Thank you so much. Thank you, Oscar. Yes, when I differentiate the first function, I get 3x squared times the second function plus the first function times, careful now, because p is a function of x, 2 times p times dp over dx equals obviously 0. Let's see if you have questions on this. Is this okay? And then we'll continue. Is this okay?
Yes.
Perfect. Okay, so now I have to solve for this. This term will move to the other side. I have to change its sign. So 2x cubed p dp over dx equals negative 3x squared p squared. I divide by this, dp over dx equals 3x squared p squared over 2x cubed p. Yes, I will try to simplify it. A p from the bottom with a p from the top. 2 x's from the top, 2 x's from the denominator. So dp over dx equals negative 3p over 2x. 3p over 2x. This is left, this is left. Any questions?
How did you get the negative 3x squared p squared?
I move it to the other side because only this term has the variable. This does not belong to this side. I have to move it to the other. When I move a term from one side to the other, I only change its sign.
Okay.
Better?
Yeah.
Perfect. Do you feel the need for another? It's okay if you say yes. Do we feel the need for another example?
I do need another one.
Yes, feel free to choose anything you want. Any? Which one?
33.
Which one?
33.
Okay, 33, that's good. So let's look at 33. Let me copy it. In 33, we have x squared p plus xp plus 1 over 2x plus p equals 1. Perfect. Well, of course, I'm going to make it easy. I'm going to cross multiply. X squared p plus, plus 1 equals 2x plus p. When you cross multiply, x squared p plus xp plus 1 equals 2x plus p. Now, I know what they want, but let's double check. Yes, they want to find us to find dp over dx. Excellent. Good. So, product rule. 2xp plus x squared times dp over dx. Do we understand this step before we continue? Plus another product rule. First function prime is 1. Plus the first times the second function, but that's a function. Prime, but that's a function, so I have dp over dx. 1 prime is 0 equals 2x prime is 2 plus p prime, but that is dp over dt. It's dx, not dt. Okay, so now this is just simple algebra. What do I mean by that? Well, this is what I'm after. All these terms have to be on one side. The other terms have to be on the other. So I will leave these two here, but I will move 2. And I will move these 2 to the other side because they don't belong on the left-hand side. But again, this is simple algebra. This is not calculus. Okay, so let's do just that. So 2xp plus p minus 2 equals. I'm going to factor out dp over dx. From here I have a negative x squared. From here I have a negative x. and from here I have positive 1. So let's redo this step one more time. So the first function prime is 2x times the second one plus the first times the second function prime. First function prime is 1 times the second plus the first times the second prime. 1 prime is 0. 2x prime is 2. P prime is dp over dx. Then I kept these two terms here, but I moved 2, so I changed its sign. This moves to the other side with a negative sign. This moves to the other side with a negative sign. These 3 terms have a common factor. Now I'm solving for this, because that's the only variable here. dp over dx. This over this. And that is final.